We are going to begin a unit on exponents, and we need to review some rules before we get to the main part of the lesson. If you have a variable with two exponents, that's an a, and so x to the a times x to the b. Fix that. You're going to add your exponents, so a plus b. If you have a power that's raised to a power, you're going to have x times a times b, x raised to the a times b. Now, this is also the same as if you switch those powers, okay? It doesn't matter which order you multiply a and b. A times b is equal to b times a. These are going to be the same. Okay, so those are going to be the same. Another rule that we will be using is if you have a negative exponent, all that tells you is that you're going to switch the location of your variable. So for practice, let's review these problems. You will need to stop the video at this point. Write down your answers, and then come back and check your answers. Okay, here are the answers to the problems. With the first one, you are going to add your exponents. Your second one, you're also going to add the exponents, but only of the like terms. The third one, you have powers raised to powers, so you're going to multiply. The power on the a is 1 originally, and then you multiply it times 3. With number 4, you do the opposite. As what you did with number 1, you're going to subtract your exponents and get m to the 4th. Number 5, you're also going to subtract your exponents, but what you see is that your denominator has the larger exponent. So you could either write it as 1 over n squared, or you could write it as a negative exponent. And then the last one, we will distribute that 2 and square both of those powers and get x to the 6th over y to the 8th. Now, this page is all about some rules we're going to follow. We are going to begin by writing this as a power. Now, writing these as a power, so these are rules, and I'm using some actual real numbers for these rules. A square root has a power, has an exponent, and it's 1/2. So what you can see is that the number right here in the root is a denominator. So we would have x to the 1/3. And then the bottom one here, we have x raised to the 2/3 power. Well, the denominator, right there, that 3, that's our root. And the squared is a power. Now, we can do a couple of things to get this answer. We can go x squared raised to the 1/3, because 1/3 times 2 is 2/3, or you can say x to the 1/3 squared. So if we write it like this, we'll get this answer. But if we write it like this, you can write it an equally appropriate way. Cube root, and then square it. These are all the same. Okay, we're going to simplify these. Now, a 1/2 power means a square root. And then the square root of 81 is 9. Now, you're used to us writing a plus or minus sometimes. That is if you're solving. We're not solving, we're simplifying here. Now for the next one, we have a negative exponent, which means we first need to make it positive. So we make it positive by moving the number that has the negative exponent to the denominator, and then we take a 5th root of 32. Now, not everyone knows that the 5th root of 32 is 2, but you can do this on your calculator and go to the math button. And before you do the math button, actually, what you're going to do is you will write 5, and then hit the math button, and then find the button that has this, and then put 32, because it'll offer you parentheses, and then hit enter, and that will give you 2. Okay, so for number 3, now what I notice here is I have a negative right there. Now that negative is not raised to the power. If it were in parentheses, it would be raised to the power, but this is not raised to the power. So we're going to leave the negative alone. And we're going to write this as a cube root of 8 squared. And we're going to keep the negative out there. And the cube root of 8 squared, so 8 squared is 64. Keep the negative. And then the cube root of 64 is 4, so your answer is negative 4. Now an alternate way to do this, that's also correct, is to say, well, I want to take the cube root first. So you'll have the cube root of 8 and then square it. And sometimes it works like this, that you can do this. And when you take the cube root of 8, you get 2. You square that. Now the square is not squaring the negative, it's just squaring the 2. Alright, we have these words right in exponential form. What exponential form means is that we want exponents that are fractions. Now I have a square root. The square root tells me I have a power of a 1/2. So I'm going to start with that. And then I'm going to distribute my power. I have powers raised to power, so I'm going to multiply them. So that gives me a to the 1/2 times b to the 3/2. Okay, now this next one, I want to write in exponential form. And I have a number. So I've got, before I do that, we had a lesson before where we actually reduced a lot of things. If you know how to simplify this and this using that power, then you can do that. But I'm going to begin by going 8 b to the 6, c to the negative 4, 1/3. Okay? And then you distribute that 8 to the 1/3. That means a cube root. And then 6 over 3. And c to the negative 4 over 3. Well, when you have, even if it says exponential form, you want to write it simplified. So the cube root of 8 is 2. And then you're going to have a b squared. And then you'll have c to the negative 4/3. And that doesn't simplify, so you're going to leave it as it is. Express in simplest radical form. That means your answer is not going to have fraction exponents. You're going to write it in a radical. Now, what I see, when you multiply the same things together here, you're squaring them. So I've got the cube root of 4. Square that. Now what we learned before is that power can either go outside the radical or under the radical. Now 4 does not have a cube root. So I'm thinking I'm just going to move that square underneath that radical like that. And then that gives me the cube root of 16. Well, let's think of factors of 16 that are a perfect cube. Well, 8 is, so 8 times 2. And 8 is 2 cubed, so it gives me 2 cube root 2. Okay, now let's look at a division one. And I want to begin by writing it as a division problem. Like this. Okay, so what might be the easiest thing to do is I need to keep my 6th power. When we have the same root, we can put things together under the same radical. So I'm going to make a big fraction radical like this. And then I'm going to actually evaluate a to the third, which gives you 512 over 16. And then when you divide 512 divided by 16, you get 32. Well, I'd like to be able to reduce that, but 32 is the same as 2 to the fifth. We have to bring things out in groups of 6, and so we can't do that. So this is your answer right there.